YouTube.
Need to get some decent tunes for you so you can play them locally.
Well, so yeah. So actually, interesting thing. Now that we're like working towards, now that we're like a YouTube partner, they like actively demonetize my streams if I don't play music that isn't like copyright free stuff. So this is like copyright free music. Yeah, because I was noticing that on now that we're like monetized and stuff, they get a little bit more aggressive at telling me that you can't play that music, or we're just gonna like take all your views. I'm like, oh, okay, well, fine. So I'm experimenting. This is like some playlist I found that's just generic copyright free stuff. It's just, you know, background noise. Unless you want to like compose some music. If you want to start using Suno to, cause AI generated music probably doesn't trigger any copyrights, right?
No.
Yeah.
We need to find something better than YouTube. All these companies need to just fail today.
Yeah.
Enough is enough.
Well, it's where all the viewers are these days. Well, a lot of the viewers are on YouTube, so kind of have to gotta go where the viewers are, you know. Let me see if the live source is up. Okay, now it is. Yeah, sick. Okay, cool. All right, now we're on YouTube.
Well, here's what you do, right? You start up your own video streaming platform, and then you just plaster New York with all these pamphlets. Problem solved.
Oh, Sib says, "Hey, what's up, Dr. G? I saw my grade on my UCI. Yeah, congrats, Sib. Sib got an A. Sib got an A in the class. That's why. Yeah, I couldn't. I was supposed to do Jackbox with people on Sunday, but grades were due, and I was too swamped. I was like, I can't do this. Yeah. So, but don't worry, I will reschedule it this week. Also, I'm gonna make some announcements. We're gonna do the talent show again. We're gonna open up submissions probably today or tomorrow for that. That was always fun. Drew says, I use Suno AI to make a Spanish rap song by Aliens for my music class. Oh, that's pretty cool.
I forgot about that stupid Turkish rap with the aliens in it.
Which one is it? Turkish rap with the aliens in it?
It's weird, like, by the time it made it to YouTube, it wasn't even complete anymore. So I've never found, like, a source material.
Oh, I see. It's just been, like, rehashed so many times. The most unique song piece of music? Interesting. Well, it probably definitely was a little bit unique. One second. I wanna fix my my skin looks a little pale. Let me fix my skin. I want to make it a little bit warmer. Where is this? Camera. And there we go. A little less medical. Okay, cool. Better. I'm meeting with my counselor Wednesday. Long story, but I'm so happy. Nice. Congrats. Okay. So, finding inverses and matrices. So, inverses come up a lot in math. I mean, you've probably seen, for instance, like inverse sine, like arc sine. That's an inverse function, for instance. So, if, let's say, for instance, you had like the sine of theta was equal to 1/2, and you wanted to figure out what theta was. Some people think, oh, I can just divide by sine. We can't divide by sine. That doesn't really do anything. What you have to end up doing is taking the inverse sine of both sides. Okay? So this is like operating an inverse function on it. Yes, good. Arc sine, exactly. And in doing so, that goes away, and then you get that theta is equal to the arc sine of 1/2, which ends up being pi over 6. That's what this ends up being. But that's one example of like an inverse that works. Okay. You've also maybe seen, for instance, if I have like 5x is equal to 10, right? And I want to solve for x. The easy way is to divide by 5, right? Another way that we think of dividing by 5 is the same thing as multiplying by 1/5, right? And multiplying by 1/5 is the same thing as multiplying by 5 to the minus 1. Okay? Look here. 5 to the minus 1 times 5. This cancels out and becomes 1. And then you just get like x is equal to 2. Yeah. So this is another example of like an inverse. Now, matrices also kind of behave like just numbers, and you can also have similar things with like inverses and things. So if you have a matrix, let's say this matrix is like a matrix A. This is how they say like matrices. That's how we write them. We have that a matrix times its inverse will end up getting you 1, which in matrix language, 1 is the same thing as just a diagonal matrix with ones on the diagonals. This is called the identity matrix. Is what we call this. Say identity. The reason why this is called the identity matrix is because if you multiply this matrix by any other matrix, it doesn't change it. Yeah. Right. Yeah. So, for instance, let's look at an example. Let's take this matrix A and let's multiply it by the identity matrix. So if I have 9 minus 6, 0, 2, and let's multiply that by 1, 0, 0, 1. If we remember from last time how we multiply matrices, right? So I take like this, and like I'm gonna multiply like this times this plus this times this. So that ends up equaling, right? 9. This is 9 times 1 plus negative 6 times 0, which that just ends up equaling 9. And then if I do for this one, right? Then I get 9 times 0, which is 0. Negative 6 times 1, which is negative 6. And so you just get negative 6. We do here to get this position on the matrix. So we do the lowest row times, let's say, the first column. 0 times 1 is 0. 2 times 0 is 0. Add them up, you get 0. Yes, multiplying one row by one column. Exactly. Yeah, you know what's going on. But notice, when I do this, right? When I multiply this original matrix A, the 9 minus 6, 0, 2, by the 1, 0, 0, 1, I get the same matrix back, right? So this is why we call this the identity matrix. That music's way too loud. Karate in the garage, dude. What's this? Yeah, I'm gonna try a different song. Chill Nights, I like that one. Yeah. And sometimes we'll write that like this. This is kind of the thing that denotes like identity matrix. Okay. So in order to figure out the inverse of a matrix, I want to find what matrix, when I multiply matrix A by it, that I get the identity matrix back. That's how this should work. It turns out there are tricks for them. So for a simple 2x2, what's up, Taco? Yeah. So for a simple 2x2 matrix, I believe you switch the rows and you switch the diagonals, and then you well, one sec. There's a rule for it.
Rotate. The down.
Well, it is kind of like rotating things, but let me see. Inverse. What's different? Well, we're doing. Wait. First of all, why am I on Bing? I don't want Bing. Sorry, what? Yeah, this is what it is. Yeah. Yes. So, yeah, you switch the diagonals. So whatever this is goes here, and whatever this is goes here. So you see how you switch these? And then you make these ones, you multiply these ones by -1, and then you need to multiply by 1 divided by the determinant. Okay. This is also called, like, determinant of A. And we'll learn how to figure out determinants. So, for our example here, right, which was, what was it? 9, negative 6, 0, 2. First, let's figure out what, like, the determinant of this is, okay? The determinant of a matrix, if it's a 2 by 2, you do this times this, minus this times this. So it's 9 times 2 minus 0 times negative 6. 0 times negative 6 is just 0, right? So this is just equal to 18. So, if I want to find the inverse, I do 1 over the determinant, so that's 1 over 18, times our new matrix, so we're going to flip these. So instead of being 9, 2, it's going to be 2, 9 on the diagonals. And then it's going to be 0 times negative 1, which is 0, and negative 6 times negative 1, which is just 6. And so then this is your new matrix, which you can distribute the 1 over 18 in, and that becomes 1 over 9. 6 over 18 is 1 over 3, 0, 1 half. So there we go. So that is A inverse. Okay. Now let's. Why do you flip the sign in one diagonal and not the other? It's just what the rule is. The rule is just like you switch these and then you multiply these ones by negative 1. But 0 times negative 1 is just 0. And then negative 6 times negative 1 is just 6. As to, like, the exact reason why we do any of this, I don't technically know. I just know what the rule is. Zach probably knows. I think during his stream, he went over matrices last week, and I think he showed how to take the determinant of... Not the determinant, sorry. To find the inverse of even higher dimension matrices, and why it takes so much so long. Honey says, because you were summing the cofactor. Oh, okay. That's interesting, Honey. I don't know what that means. You were summing the cofactor. Let's check to make sure that this works as an inverse, and then we can do a little bit of a dive into why we did that. I'm actually curious to know what the cofactor means. But okay, so let's see if we took our matrix A, which was 9 minus 6, 0, 2, and then let's multiply it by this. Okay, let's see what we get. So now we have A times A inverse. Okay. And so if we go around, right, 9 times 1/9. Ooh, okay, cool. That's going to be 1, right? And then minus 6 times 0 is just 0. And then for this one, we have 9 times 1/3. So that's going to be 3. Plus negative 6 times 1/2, which is minus 3. So that gets me 0.
Surprisingly accurate.
It is true, okay. This times this is also 0. And then 0 times this is going to be 1. Yeah. So look at that. We get the same thing. Sensation, you know they're doing a thing where people are getting on... Oh, wait, I got to get rid of my camera thing here. Sorry. People are going on to, like, dating apps and putting down, hey, for our first date, can you help me, like, make this furniture? Like, they're getting people to go on dates with them so that they can get free help for, like, putting their IKEA furniture together.
Huh.
Yeah, it's pretty funny.
I feel like that isn't a new thing somehow.
Yeah, I saw it on the news or something. If something were like, instead of people hiring people to make their furniture, they're now just like putting it in their dating description. You know, like a perfect date looks like you come over and we like build like, I don't know, the Scourge or whatever weird name IKEA has for stuff. Yeah, it's pretty funny.
Come over and help me build mirror.
Dude, the words for things in IKEA are because it's Swedish, I guess, right?
Yeah.
Yeah, they just have weird words for things. Yeah. I will say, like, it is actually a good dating test to see if you and someone else can can build IKEA furniture together, because I don't know, it tests a lot of like cooperation and patience and, you know, general togetherness, compatibility, if you can like put stuff together, especially IKEA.
See, here's the way it would have to work with me. Like, I'll come and help you build your furniture, then we'd build the furniture and everything would just get done as quickly as possible. And it's like, can we go get drunk now, please?
like here, I built it. Yeah, but are you supposed to, you know, give them little tasks and, you know, make it more of a collaborative thing? Or, yeah, do you just steamroll it and just do it all yourself and say, like, all right, but, like let's go do the other things? Like, an interesting test.
It's like, well, no, because we double down. I mean, there's a whole joke about the Scottish, you know, perspective on building furniture and being given a set of instructions. It's like, Scottish men don't read sets of instructions.
Yeah.
Even picking them up is tantamount to admitting homosexuality. It's just like you'll see a Scottish guy pick up a leaflet or whatever and just go, that can get to fuck.
Yes, I don't need the manual. Don't need it. I hate manuals. I don't really read them either. I'm just like, I can figure it out. It's not that bad, right? Your hat is cool. It's like an illusion. Is it? I don't know. It's like an illusion. That's cool. Oh, I see. It is kind of it's holographic. I think it's holographic is the term. Ooh, yeah, it is pretty cool actually. All right. Okay. So matrix works, right? We found an inverse. Awesome. Someone said something about like cofactor. Oh, Sib, you submitted a question as well. Let me see what Sib was doing eventually. Okay, we'll look at that. I hope it's not tensor products. The circles keep on getting bigger and smaller. That's cool. Now, for a 3x3 matrix, it becomes like it becomes a huge pain, I'm pretty sure, to like figure out like what a 3x3 matrix is. Inverse of a 3x3, and I think Zach did this. He did a whole explanation on his stream about. Oh wow, yeah. This is a mess. I remember what you do here. This is actually really cool. Yes. What do you... I see. You don't know what a tensor is? It's okay. I don't really either. Yeah, I think I remember what you do here now. Yes. Okay. This is actually really cool. How you do a 3x3. And technically what we did here, yeah, this is called the adjoint of A, which usually they write with like a T. So this would be like A adjoint is what that's called. But if you wanted to, for instance, figure out the inverse of a 3x3, it's uploading. Come on. I know you're right there. You're right there. You got it. Okay. Let's say this is the thing you want to find an inverse of. Okay. You set up your matrix here, and then you set up like, it's called an augmented matrix because you create another matrix to the side of it, and this is the identity matrix. And then your goal is to somehow turn this into this by doing row operations, but every time you do a row operation, you have to do it to this one as well. So for instance, what they do to start is they say, okay, well, let me like take this row and swap it with this row. But if I do that, I need to swap these two things as well. So that's why this then becomes 103, but then this swaps up here as well, and that's why you get 010. Yes, we did do an augmented matrix for solving a 3 variable systems of equations. Yeah. In that case, we just had like this, and then we had like this. This was the only thing. We only had one extra column. That was the augment. And then we did RREF, which is a calculator function. I am afraid of when matrix is mixed with PNC. What's PNC? But yeah, so it was by Taco Cat. Yeah, it was Taco Cat's question. So you just go through a bunch of different row operations to try to turn this into 1, 0 into the identity matrix, and then whatever happened here, now that's your inverse. Yeah, that's another way to do it. That's pretty cool. But yes, we did use augmented matrices when we were solving a 3 variable systems of equations. We just had like an extra column. Cool. Yeah. You most likely will not be asked to figure out the inverse of a 3x3 or higher matrix. It's pretty annoying to do. And that's why we have calculators. So, yeah. Cool. Okay. Let's see. Sib, you have a question. And again, if you're watching us here from YouTube or whatnot, please use the link at the bottom. You can submit a question for us to go over. Permutations and combinations. Oh, okay. What's up? What's up, Sensation? What were you gonna say?
I found it. It's on that timestamp there. Just only play the audio because they'll probably kick off otherwise.
Kevin Bridges, you pay mental. What is this?
Just from that timestamp.
Okay, let me play it.
Here's how we created our custom.
Let's see. I gotta have ads. Skip. Okay.
My dad is of the old school, where the use of an instruction manual is viewed as an admission of homosexuality.
He's a Scottish guy, this guy? That can get the fuck. That's pretty good.
That can get the fuck.
The fuck. That can get the fuck. Nadish says permutations and combinations when the questions came. Oh, I see. Yeah, okay. PNC, permutations and combinations. Yeah. That's like a lot of probability stuff. Yeah, matrices are really cool, Drew. I'm glad you asked about them. They're used a lot in computer science. They're used a lot for like graphics. If you want to get into like video game design or anything, lots of matrices. And the whole class that you can take that really deals with matrices in math is called linear algebra. So, is Sensation British? Don't call him British. He doesn't like being called British. Your friend has an accent like his and is from the UK. Yeah, he's technically Scottish. Technically, right? Yeah.
There's no technically about it.
Yeah.
I've just lived in England for a very long time.
Right. But ethnically, he's Scottish. Yeah. All right. Let's see.
Interestingly enough, there is a genetic discrepancy. So
there's a discrepancy. Yeah.
There's a genetic discrepancy we had of different races, literally speaking.
More like Nordic or something, right?
Older
than that. I think about like the Vikings.
The Vikings didn't come across until what, 2, 3, 4,000 years later.
Yeah.
I don't even know exactly. In terms of history, the Vikings are reasonably modern.
What, the 1200s? 1500s? What are the Vikings? Not 1500s, sorry. No, the Vikings are like the 800s.
Yeah, so, the Danelaw was like 800 AD.
Are we going over eigenvectors? We can. If you want to submit an eigenvectors question, I'll do one. What we're doing here is vector fields. This is Sibley's question. She says, consider a vector field G satisfying G of P is equal to Tu of P minus 3 TV of P at every point P of S. Evaluate G dot ds. Recall the definition of a vector surface integral. G dot ds is equal to G dot n ds, but since n is normal to both tangent vectors u and v, we must have G dot n equals 0. Therefore, it's just equal to 0. Okay. Yeah, I mean, this involves like a lot of definition stuff. Like, first of all, what the hell is Tu and TV? The C component is find a parameterization of GUV for S, and then compute TUTV and the normal vector. Oh, okay. I'm guessing that, like, TU and TV is DG DU. Is that how we think? Yeah, I mean, so parameterization, right? GUV is, oh, interesting. They do it like this. I feel like this should be like a bracket though. Because wait, this is a variable of 2 functions, but then they say it's now a variable, wait, a function of 3 variables now? This is a function of 2 variables. And now they say has like 3. Where I think this is like X, Y, and Z. Which makes, you know, they're saying, oh, we'll have X just equal U, have Y just equal V, then Z is equal to X squared plus Y squared square root. So then Natish has a question. For how many values of P, the circle X squared plus Y squared plus 2X plus 4Y minus P equals 0, and the coordinate axes have exactly 3 common points. Oh, interesting. That's a cool one. Here, let me highlight that one. I'll do that one in a bit. But yeah, for this one, Sib, I think TU, which, yeah, is a tangent vector. And remember that tangent just means like derivative. So TU here, for instance, is equal to, I think it's partial G, partial U. And then you say, or no, actually, you know what? I think TU is this. I think it's nabla U G. Because this means it's going to be equal to dg du in like the U hat direction. Sing K-pop Demon Hunters. What's up, got bit by a dog? I'm sorry if you got bit by a dog, dude. That's an interesting username to pick. You want to tell us a little bit of history about that? So, yeah, here for dg du, right? This is 1. dv du is just 0. And then this becomes, this is a chain rule. So, ddu of u squared plus v squared to the 1/2 is then 1/2 u squared plus v squared to the minus 1/2, which is then what this is. And then, right, and then tv is equal to dg dv. I don't have 7 PhDs. Do you have a PhD? Yes, 7. I have 1. I have 1 PhD. I couldn't imagine getting more than 1. I know some people that have multiple PhDs. That seems like really difficult. But yes, at ClickStar, I do have. If you ever want to read my PhD thesis, you can. What's up, EOS? Yeah, this is my this was my thesis. If you ever want to read it, I'll give you a link to it. Yeah. Okay, so this is kind of new to me, Sib, as well, but yeah, it seems that the tangent vectors are found by just doing the derivative of the function with respect to one of your new parameterized variables, which is either u or v. So you do dg du, and then you do dg dv. What even is this? This or my thesis? This is cool. I mean, this is like vector calc is what it is. And then how they're figuring out n here, I think what they're doing is they're doing TU cross TV. Because in order to figure out, like, the normal vector to a plane or a surface, you need to figure out the cross product of, like, two vectors in that plane. So, the cool thing about cross products, right? So, if you have, like, let me see, like, images, cross product diagram. Yeah. Khan Academy, yay, they're decent. But yeah, and also this has to do with matrices. So you were smart and brilliant. This is why I think about it. It's okay.
He asked that last year.
He asked me it last year. Did he?
He asked you that. Well, not exactly the same question. He asked you if you were a teacher, I think.
Oh, did he? Oh, that's too funny. I'm an open book. I have 7 PhDs, though. Yeah. Okay, so Sib, if you have like two vectors here, right? These could be thought of as like tangent vectors to like a point or something, right? The normal vector is then the cross product of those two. Because if the cross product of two vectors has to be perpendicular to both vectors. And if these two vectors lie in the plane or the surface or whatever, then this is going to be perpendicular to that surface. I do know about JEE. Yeah, I get asked a lot of questions by JEE sometimes, but so yes. Okay, so here's a cool thing.
JEE exam.
Yes, you do. You take it and then you escape poverty.
No, you take it, you rip it up, and you shout, "Ben Killer."
If you wanted to do this cross product, this is actually really cool. This is a matrix as well. So I think what you end up doing is you would do like, this would be like I hat, J hat, sorry, K hat. And then it's going to be 1, 0, and then the U over the square root of U squared plus V squared. And this is going to be 0, 1, U over the square root of U squared plus V squared. Yeah. What's up, Famish? And then, so you do this trick, right? So you do the determinant of this, which is going to be 0 times this, which is 0, minus 1 times this. So that's why you get negative U over the square root of U squared plus V squared. And then you do here. So then it's minus, and it's this. Now it's this times this, minus 0 times this. So that's why you get this. And then over here, when you do the final one, then it's this times this, which is 1 times 1 minus 0, which is where you get 1. Just programming. You're learning data types. That's cool. Nice, Famished. Currently
0
on
is
loops.
not an int.
0 is not an int. Yeah. Do you index your arrays at 0 or 1?
0.
I think I should always be at 0. Correct me if I'm wrong. I think Python starts at 1 though. No. There's always some weird thing. There's some weird thing where like the 0th indice like denotes the size of the array, I think. Correct me if I'm wrong on what language does that. Or we can look this up actually, sorry. Let's go ask, a coding thing, ChatGPT. Let me see, like what common programming languages start their arrays at 0 and ones start at 1. Okay, so the ones that start at 0, C, C++, all these start at 0. Okay. Here's the interesting thing. MATLAB arrays start at 1. So MATLAB is a very common language that you'll use in like college if you're doing like data analysis. Ooh, wow. Yeah, so MATLAB, Fortran, Julia, R. Yeah, I remember R. Yeah, R is like a statistics coding language. Visual Basic. Apple script. Interesting. So I think in so wait, for the languages that start indexing at 1, what do they have? So I believe in MATLAB the 0th index indicates the size of it. Yeah. Okay, wait. MATLAB actually, the index 0 is not valid. Not valid. Not valid. Oh, well. You're welcome, Sib. Yeah, I thought some of the coding languages have the 0th index like show the size of the array. I think it's what it is.
I'm not even sure how C keeps that data.
Yes.
It just is.
Yeah, it just is. The other cool thing is that you can have negative indices, right? So if you go to the -1 index, it goes to the last item in the array usually. And like -2 is like 2 from the end. -3 is 3 from the end. Have you seen that before?
In Python.
Maybe in Python. Yeah, maybe Python does it. I know for sure, like, the coding language I used, IDL. I know IDL, for instance. If you use negative indices, it starts from the back. Nice. Yeah, honestly, like, pseudocode is great, and then all the syntax is just like, you know, learning a new language, basically. If you understand the gist of what you need to code, figuring out the syntax is what you can have like AI just basically figure out for you, and then you could double check to make sure the syntax is all right. Wait, we had another math question from someone. What was it? I could find it. No, where'd I put it? One sec, I'll go find it.
What did you do this weekend? Local man paralyzed after eating 413 pieces of garlic bread.
Oh, God. Dude, that sounds delicious, though, by the way.
413 pieces.
Natish. Let's see what... Natish has a question. There you go. For how many values of p does the circle x squared plus y squared plus 2x plus 4y minus p equals 0 and the coordinate axes have exactly 3 common points? What's up, Equity? Good to see you, dude. So I think what they're talking about, right, is that if you had like something like this and then you have a circle, are you asking, I guess, well, here it'd have, okay, so for it to have exactly 3, you need something like this, right? Because then it would hit here, it would hit here, and then it would hit once here. Anywhere else, it's going to have 4, right? 1, 2, 3, 4. Okay, cool. So, for how many values of p? So, you need either to do something like this, or you need it to do something like this, for instance. Like, it has to be tangent to one of the axes, at least. Here it would have 0 common points, and then here exactly it would have 2. Okay, that's kind of cool. All right, so first off, I don't like this form. I'm gonna try putting it into like vertex, or what was it called? Standard form. Not standard form. This isn't standard form. Well, you know what I'm talking about. Like, okay, so here we go. X squared plus 2x, and then we're gonna have y squared plus 4y, and then we're gonna say is like equal to p. All right. So what I did is I just moved the p over. Okay. And now I'm gonna complete the square here. This is where like completing the square comes in handy. So this would be, we're gonna say like plus 1. What you do is you divide this by 2 and you square it, and then you add it on both sides. So this is going to be plus 2 squared, and this is going to be plus 2 squared. So that's going to get me x plus 1 squared plus y plus 2 squared is equal to p plus 5, right? Okay, so we have a circle that is centered at -1, -2, right? This is the form. X minus h squared plus y minus k squared is equal to r squared, where h comma k is the center of the circle. Okay, so my circle is at -1 and +2. So if we were to draw this, right? Sorry, -1, -2, right? So -1, -2 is the center. What's up, Ethan?
Good, how's it going?
How's it going?
I have some good news.
What's your good news, dude? Tell us.
So today I officially started college.
You officially started college. Congrats, dude. Here,
Yeah.
I gotta get you you have a new role now. I'm gonna give you a role. There's a role called Achieved College.
No way.
Yeah,
Achieved college?
Achieved College, yeah. It's a role on our server. Yeah, now you have the Achieved College role. Congrats, dude.
Alright. Thanks. Hold on. I'll get back to you. I'll get back to you. Hold on.
Okay, you're good. Thanks, Sib. Sib says I was watching your YouTube shorts. You like them? Yeah, they're kind of fun. I need to start doing those again. I think I will once I get back from Burning Man. Now that the school year has started soon, or will be starting soon, people are more likely to watch them. If you release educational content over the summer, the engagement's garbage. No one really wants to watch them. But I'm glad you're watching them, Sid. That's fun. Okay, so I have a circle that's centered here, right, Nadish? And I want it to intersect at 2 points. Or sorry, 3 points, right? So I think I want the radius to be 2. Do we think that's right? Because I want it to touch once here, and then I want it to touch here and here, which is 3. So I think you, yeah, you're welcome, Jason. Jason's asking, what age level is this question for? This is high school probably. It's a high school question. I would say maybe 9th grade, 10th grade. Oh, okay. So I want this to equal 4 because it's radius squared. So p plus 5 is equal to 4. So I would say p is equal to -1. Nadish said this is an 11th grade question. I could see it being 11th grade, yeah. What's the Hindi sensation? What's that even mean, dude?
I can't even say this one, but yeah, it's like, hey, you roundish, useless circle.
Here, let's see what I always like to see what ChatGPT thinks. Just curious. Solve it. Let's just see. I think p is -1. And I don't know that it could happen another way. Wow, Obi with the raid. What's up, Obi?
Good job.
Shout out to Obi. Obi's a G. And we got Zach. It is GPT-5. I actually really do not like GPT-5. I don't like what they did with ChatGPT. They got rid of all the models. I understand that it's easier for the layperson to now use ChatGPT, but I don't know, for any sort of I don't want to be pretentious and call myself a power user, but for anyone that had a little bit of technical knowledge and was using it that way, Kind of sucks. Okay, let's see if it got it. Okay, so there are two values. It says -1 or 0. In Syria, we took these like 6th or 7th grade. And, well, maybe you did. I don't know, but is Syria still like a country anymore? Are they okay?
I'm sorry. Where was I 20 years ago? No, we didn't. So wait, is 0 also? How can 0 be 1? Sir, please consider when the circle passes through the origin. Oh, I see what you're saying. Okay. That is a good point, Nadish, yeah. So I was considering when it passed, when it was like tangent to this point and then hit these two. You are correct that there is an additional one that can happen. And that's if it passes through the origin and then here and then here. Oh, very cool. Okay. So, and yes, in order for it to pass through the origin, you need the radius to just be, yeah, the square root of 2 squared plus 1 squared, which is square root of 5. So P would be equal to 0. Cool. That's a cool question, actually. Nice. Good job, Nadish. This is a fun one. I like this. It's a good question. We chatted about Peter Lijedal's Building Thinking Classrooms, a recent addition to my math pedagogy repertoire. Chapter 4, how do we arrange furniture? That's literally what Sensation was posting earlier, dude. That's what he was posting here. Arranging furniture. Lil Ye doll. Using the instruction manual is an admission of homosexuality.
Sensation has some interesting opinions on things.
My opinion.
It's just truth. Let me see what else. So, yes, this was a good question. Appreciate it, Nadish. The general strat, whenever I see stuff with, exactly 1 point or exactly 3 points, you want to try to get something into this vertex form. And the way to do that is to always complete the square. So this is why we learned to complete the square in early algebra, probably. And it gets used so many times in other classes. So good. Let's see. Where's my Discord? If you have a question, anyone else who's watching, please, use the link down below. We'll go through it. We got another one coming up here from Equity. Wow, okay. This is an AP Pre-Calc. I think AP Pre-Calc is a cash grab by College Board. Because I don't know, what classes it really counts for in college. AP Calculus, I understand. But, AP Pre-Calc, what? You don't take Pre-Calc in college. I guess you could if, you're in, a super not math-heavy program. Pre-Calc, yeah, right? Wow, you asked ChatGPT how to solve the question. That made me ask Gemini what level the question was for, and it told me grade 11th pre-calculus. So well done to that other commenter who said grade 11. Well, I think they were literally in grade 11 when they asked it. Yes, if you start it under college algebra, yeah, which is very low. What? Excuse me? We get college algebra plus trig for 4 out of 5 around. Oh, I see. Oh, if you get a 4 or a 5 on the AP pre-calc exam, they give them college algebra credit. That's cool. I thought most colleges start with just calculus. You gonna say something, Sensation? What's up?
Doesn't that put you behind them?
Kind of does, yeah. I mean, you start at calculus, unless, again, you have, I don't know, some basket weaving degree that, just requires bare minimum math, then sure, yeah, college algebra. But most
dance theory.
underwater basket weaving or something. But most, like, you know, degrees, especially if it's like engineering or any sort of STEM major, you have to take calculus usually, and that's like the bare minimum. But I guess for some other programs that are more like, you know, liberal arts in nature, you could probably get away, I guess, with pre-algebra, or what was that? Sorry, pre-calc. Yeah.
See, I'm not even convinced we have pre-calculus.
Pre-calculus is just trig. Pre-calc is, again, apparently this is pre-calculus, but pre-calc is just an umbrella term for anything that is a tool that you need to know to do calculus. So, for instance, completing the square is kind of like a pre-calculus thing. You need to know completing the square to do calculus. Any sort of like sine and cosine stuff is pre-calculus, which is, I guess, technically also trig. AP pre-calc BC. Is that a thing? Is it? Stop. Is there an AB subscore for AP pre-calc? Don't tell me that, Zach. Don't tell me that actually exists. Yeah. Y'all need my math nights. Yeah, we do. But yeah. Pre-calc is just like an umbrella term for the tools you need to learn to do calculus.
See, again, we just take it to an extreme, and it's like, here's basic maths. This is everything you need to know.
Yeah, basic maths.
That's in there. Trig's in there. It's like, here's GCSE maths, and it's just all sort of lumped together. Well, and then it's A-level maths. There isn't really any separation of identity.
Oh, Obi's saying he taught the 5 credit hour functions and trig class. Wow. Okay, so you actually taught like one of these, like, kind of like these basic maths classes then. I agree with Zach saying that some colleges are moving towards requiring statistics instead of college algebra, instead of like their version of like the basic math requirement is now stats, which I think to students who are not really interested in math, like stats has more direct applications and feels more relevant, I guess, than learning about sine and cosine.
Oh wait, yeah, there is a separation of identity in the vaguest sense. There's A-level mathematics, and then there's A-level applied mathematics. Applied
math, yeah, okay, sure, yeah, I can see that.
So there is a distinction, but I'm pretty sure stats again is just in A-level.
Stats is very useful. I love stats. Okay, these are matrices. So again, Drew's asking about matrices earlier. We did what did we do? Yeah, we did how to find the inverse of a 2x2 matrix. Oh yeah, by the way, Drew, here, I'm going to shout out Zach as well. But go check out Zach's channel. He was talking about doing inverses of 3x3 matrices, I believe, on his stream last week. So Drew was asking about how to do it for a 2x2, and so we showed like some basic tricks, and then I kind of teased at what you would need to do for a 3x3. Is this the method you went over, Zach? Sorry, I didn't watch all of your stream, but I know you were talking about it. Did you talk about this method for finding inverses, or was it a different one? But okay, here's more matrix operations. So again, when adding matrices, they need to have the same dimensions. Okay, so in this case, this one is a 2x2, right? It has 2 rows, 2 columns. Zach says, we didn't talk about it. I was trying to explain where the diagonal method of determinants comes from. Oh, wow. Cool. Method 1, swap shit by Mathemagic. Yeah. Well, that's the adjoint, right? Yeah. That's what this is. And actually, so Drew was asking me about that. He was like, wait, why do you like switch these but multiply these by -1? And I didn't know the answer to it. I just know it's called the adjoint, and that's how you do it for 2x2.
Hello, I'm here again.
What's up?
But also, wait, just to explain that thing really quick. I mean, I had that same thing.
You have the same thing? Same what?
Like, it's like about that matrices thing. It's like with leading and non-lead leading numbers from what one of my professors said. You multiply the leadings
Leading
and
numbers
non-leading.
non-leading? Yeah, what's happening? Sorry. What?
It's like the leadings are like both leading and non-leading are diagonals. It's like the leading ones it's like the two ones that are from left top to right bottom. If you know what I mean.
Oh, okay, okay, okay. You're talking about the diagonals. Are you talking about these?
Yes.
Those
Yeah,
are called the
the
leading
leading
terms. Oh, interesting.
Yes. That's what my professor calls it. And I mean, hey, that helped out.
I mean, it's not
And
bad.
then the non-leadings are just the ones that are multiplied by -1.
Mm-hmm.
But yeah,
Yeah, that's how
So,
we are doing more matrices. Shantrix is like, I kept your stream in the background. We're doing more matrix. We're doing like matrix operations. What were we gonna say, Ethan?
yeah. First day of college, to be honest, it was pretty chill. It was pretty chill.
Nice. You guys trying to drown me, dude. Trying to drown me with water.
Tell me, like, you want to ask me any questions based off that?
Yeah, I was gonna say like, what classes are you taking at college this year?
Well, there's the obvious math and English. Like, those are
Sure.
like pretty much mandatory.
Are you taking calculus?
I'm not in there yet, sadly. Like,
That's
even
okay.
though I did so well, even though I did I got the highest placement. Like, well, not the out of all, but like I scored so high that I got the highest placement possible. But that's not even close to. That's not even so close to pre-calculus.
Are you doing like trig or college algebra?
That I put in like intermediate algebra. Yeah.
Intermediate algebra. Okay, that's cool. I'm pretty sure you can do this
To be
stuff.
honest, that's just sounds so easy. I feel like I did that in high school though.
Okay. Well, then you'll smash it, dude. Like you'll get all A's, and that'll be great. You know.
Actually,
I'll make me drink water. I need to refill my water bottle. 1 sec.
Oh, for real? So much water drained to the point that you have to refill it.
Okay, more water. I thought
Yeah, so-
I thought we had a timer on the hydrate. You can't redeem like hydrates back to back. Did I get rid of the timer?
There's a timer. It's just a minute apart.
Oh, it's a minute cooldown. I was waiting to spam it. Oh, another intermediate algebra person. Yeah.
But yeah, can I how do I say it? Yeah,
What's
so
up?
I got math and English. I got like 4 computer science classes actually. Like I'll list them out.
4 computer
like-
science classes. That's cool.
I got systems analysis and design. Have you heard of that one?
I haven't, but that sounds cool.
That's like a methodology that's used to operate with systems and how they integrate with each other.
Mm-hmm.
There's also C++ programming.
C++ is a great language. Great language to learn. Yep.
There is another hydrate. They don't stop spamming. They don't stop spamming.
Honestly, I do need to hydrate today. I was, very dehydrated this morning.
But yeah, next there's also another one called the fundamentals of computers. I should be able to pass that.
Good.
Wait, so I think there's also college seminar actually. There's also college seminar. You know what that is?
Seminars are good. Yeah, it's like usually like you listen to like a bunch of people talk about things and stuff. Yeah.
Listen
Right.
to wait, say that again.
Like usually you have speakers and stuff that come up. Right.
Speakers. All right. And then
Yeah.
the last one I have the last subject I'm taking is networking.
Like computer networking or like social networking.
Introduction to networking.
Okay. That's pretty dope.
But it's pretty, but so far they seem easy. And
Well, it's only the first day of college. You're gonna as many of my physics students will know, like the first week is always like really easy, and then I always like warn them, I'm like, things about to get really tough. So yeah, the first week is usually pretty chill. Also because people are switching classes or like getting in and out of courses and things,
all right, but yeah, that's all my things for college for now. Today, tomorrow will be another day. I only have like English and the fundamentals of computers left. But I got one last thing to say.
What's up?
Like, you know, I don't know if anyone else has redeemed this, but just take a look at the Twitch chart really quick.
Let's see. Wow. Oh, 20,000 SCP. Wow. Wow. You had 20,000 channel points? That's nuts.
Yeah, for 1100 SCP, I'll say it's worth it. It is pretty much worth it.
Yeah. Yeah, I need to add up all your guys' kudu points that you did for the Friday thing. Sorry, I've been so busy. I'm done. I submitted final grades to UCLA today. So I'm completely done with that class as of today. So I will catch up on all the other stuff for the tournament that we're having here.
When's a physics thing due?
Pardon?
When is a physics one due? By this Friday?
Probably Friday. Yeah, I'll make an announcement. I have to catch up on a lot of stuff today, but yeah. Or I have caught up, but I need to. Yes.
Well, I'll ask a question and then we
okay,
can
cool.
move on.
All right, let's do it. Equity, you still around? Equity, Sir Bob. So, yeah, when you're adding matrices, they have to be the same size. Equity. So, yeah. Oh, nice. Good to see you. Okay, cool. So this one you can't do. And this one you can't do. Because they're different size matrices. If the matrices are the same size... Sorry, let me share my screen. Sorry. So, this one you can't do. And this one you can't do. Because they're different sizes of matrices. So, the other ones you can, and doing the operations is just adding the same points, basically. So top right adds with top right to get you the top right matrix, which in this case would be, this would be 4, -1, 10, 14, minus 11, 6. So you just do that, and that gets you that. You do that, and that gets you that, and so forth. If you have a number multiplying outside, that's also fine. The 2 just goes in and hits everything. Okay, so now that becomes 14, -16, -2, 4. And so that would be the example for that. And then you need to add them to each other afterwards. Same thing here. Ooh, interesting what's happening here. So 2x solve the matrix equation for x and y. This isn't too bad. This is just saying, for instance, 3x minus 4 equals -16. And then -1 minus 7, so that's -8 is equal to y. Yeah, this is easy. I'll do those soon. Drew, don't worry. Yeah, I usually do things on Sunday, but I was grading final grades for my UCLA class on Sunday, so I will do them soon. Maybe later tonight or something. Yeah, this is all this stuff. This one actually is a little tricky though. What's going on here? I'm curious. Oh, I think I see what happens. So wait, 2x. So that tells me that -6x is equal to 12. Okay, so x is equal to -2. Yeah. Am I going to teach at UCLA for the fall? As of right now, no. But maybe. I'm gonna ask the department later this week to meet to see what's going on. They have a lot. They're getting sued by Trump for $1 billion. UCLA is not having a great time right now. Okay, and if x equals -2, oh, y is equal to 44. Oh, that's kind of cool how this one works. Yeah.
Why? What did UCLA do?
I don't know. They're just... Trump just hates higher education. He just loves suing people. But they're claiming it's anti-Semitism, but it's not.
Oh, Jews.
Yeah, yeah. It's funny. Trump is Trump. Trump is very Trump. But yeah, UCLA is not doing too hot right now with money. So that's why I'm most likely not teaching in the fall. Hey, Chief, are you a student or you have a job or maybe both? I like to say that we never stop being students because we're always learning. I'm not currently enrolled as a student, though, at any institution. Do I have a job? I have many jobs. I do a lot of different things. Teaching being one of them. Natish. Oh, did you submit another question, Natish? I thought we did yours, Natish. Right? I hope to see you on campus, Dr. G. Aw, I appreciate that, Sib. Yeah, we'll see. Anything's possible. You taught at UCLA. That's like one of the top schools in the USA. It's my top 5 dream university. Nice. Yeah, I did. I did teach at UCLA. I taught an online summer course, and then I taught an in-person physics course in the spring. We'll see if I teach in the fall or the winter. I don't know. Okay, Ethan, here. You want to do your question? Ethan.
Sorry, we're just trying to do stuff.
Doctor teaching at UCLA. Damn, I'm new around here. This is a mad world. Welcome, Jason. It is an interesting place, Earth. Ethan, what's up? Is your mic? I'm hearing myself. Oh.
Hold on.
Yeah.
For the love of God, buy a microphone.
I know.
Hello?
We good.
Hello again?
Yes, you're good.
Sorry, like,
Okay.
listen. This is not an excuse, but I was just trying to play a game so that I could pass the time. But apparently my question's already up next.
Your question is here. Yeah, we have yours. We're doing yours. Okay.
No more of those.
Sir, I typed the question already. Did you Natish? I already did Natish's question. Did I not?
Tell him gold.
Oh, sorry. Oh, here it is, Natish. Oh, sorry, my bad. I'm pulled in. Oh, we're doing pretty well with peaks. 600 views today. That's pretty cool. Yes, Natish. I'll do yours next. Let me help out Ethan real quick because I got him. But then, yes, we will try that. Okay. The following 2 questions, 3 blocks A, B, C with masses 4, 3, and 2, respectively, are stacked on top of each other in an elevator as shown. In case 1, the elevator is accelerating upwards with acceleration A, while in case 2, the elevator is accelerating downwards with acceleration A. How does FA on B, the magnitude of the force that A exerts on block B, in case 2 compare to it in case 1? Oh. That's kind of cool.
That's not how to do it, or?
I think it's the same.
Wait, do you really think it's the same?
Yeah, I think it's the same. Oh, I should change it to live chat? Oh, yeah, sorry, my bad. Yeah, there we go. Okay, we fixed it. Thanks, Shanks. FA on B. Well, the force A exerts on B is the same force that B exerts on A, because they're a force pair. Right? So, like, if we just look at block A and block B. This is like, again, I have a PhD in physics, and this still, like, confuses me.
Really?
The blocks on top of each other, man, is always such a mindfuck sometimes. Okay. So, if we think about you always have to consider what's the force acting on the thing, not what is the thing doing on other stuff. So, if we look at block A has the force of gravity acting on it, and then it has the force of B acting on it. So we say F B on A. Okay, that's it. There's no other force being felt on block A. Block B has the force of gravity, and then it has the force of A on B. And then this force is equal to this force. There is additionally a block C. So technically, there's also this. I'm bouncing. Would like my math to be better. Love your style, but it's just above my current grade. I'll dip in. Yeah. Thanks, Jason. Yeah, Jason, make sure to go check our YouTube channel. I have some more basic like videos I do. Also, you can ask whatever questions. Like, I don't care, any grade level. And if it's too complicated, I'll just pass it off to like one of the really smart math guys that we work with as well. But yeah, if you check,
it gets passed off to me.
That's dope.
Sensations. We cover all the angles, you know, all levels. But if you want, I do like cute little shorts and stuff on math. Wait, I think there's a playlist for it actually. Yeah. Math in 60 seconds. Yeah. So,
here's how to use log rules to expand.
So for instance, like here's a video on like log rules. This is maybe like an easier math thing. Or then I do even like, you know, domain of a function, factoring polynomials, sines, cosines, all sorts of stuff. So yeah, go check out the, if you check the main YouTube channel, there's some fun little videos we do on, I would say like more basic math concepts. Yeah, cool, bro. yeah. Some of the stuff is hard, but you know. Okay, so, and then force, and then B also feels like F of like C on B. And then for the C block, it has force of gravity, force of B on C, and then it also has the normal force from the ground that it's on. Yeah, good. I'm glad the algorithm made us cross paths, Jason. That's cool, man. Okay. Now, the sum of these forces, Ethan, always has to equal the mass times the acceleration.
Alright. F is equal to m times g, right?
Well, the acceleration depends on like how it's moving. So we have one case where the elevator is accelerating upwards, which means it's getting faster going up. And then we have another case where it's accelerating downwards. So that means it's getting faster going down. Or it could be that it's slowing down going up. That's another way to have negative acceleration. But in any case, let's think about like what forces can change for the red block, right? So the force of gravity is always constant. That does not change unless you're on like a different planet or something. So if something has positive acceleration or negative acceleration, that means this has to change. So if something has positive acceleration, this has to get bigger. And if something has negative acceleration, then this has to get smaller for the sum of the forces to equal what the acceleration is. So, an FB on A is the same as FA on B. So the force that block A feels from block B is the same force that block B feels from block A. That's Newton's third law, I think, which is that for every action there's an equal and opposite reaction. So there are what we call like force pairs.
So that is Newton's third law.
Yeah, Newton's third law, right? So I think it's answer choice C here. No, sorry, it's answer choice A. Because because for case 2, the acceleration is negative. And so if the acceleration is negative, that means that this has to be smaller than the force of gravity. So
Okay,
is the correct answer A?
Nope. Nope. It's C. It's actually C.
What?
Nah, I mean, like, look, they don't have the working here, but they have the. Wait, hold on. Let me see. Hold on.
Oh, I think it's A.
Nah. I double checked. It's literally C.
Okay, well, let's go figure out why it is. I think it's... Maybe I don't know physics.
It says here, the correct answer is the one you marked, which is C.
Did they explain why?
No, they don't have any explanation.
Okay, here, let's throw. I mean, it can be wrong. Let's throw AI at it.
Hopefully that thing is wrong.
That or I'm gonna have to like turn in my PhD thesis or my diploma and be like,
no. Don't turn it in. Keep it.
Turn it in.
Analyzing contact force. What?
All right, ChatGPT says I'm right. It says choice A.
Why? But it says here that it's C.
Well, it could be wrong. People make mistakes.
I mean, oh, it's A then.
Yeah, nice. Yeah, cool. That was a good question, Ethan. It's a fun question, actually. I like that one.
EA Sports. It's in the game.
Challenge everything. You remember when it was challenge everything?
The Sims.
Yeah. What's up, Ethan?
I got 2 things. So since I'm starting out college and this is a brand new start, I wanted to see if I could get valedictorian this time.
You want to get valedictorian at college? Wow. I don't know if they do valedictorians at colleges, do they?
Not all colleges have.
You can be like the best in your department, like in your or something.
But they do actually acknowledge like the top 2 people, the top 2 highest scores.
Yeah, it's just that's very like dependent on like what courses you're taking and what major you're in, right?
Alright.
Yeah, but that's good. No, I'm glad. Yeah, try your best, dude. Let's see, Natish with another one here. H is the orthocenter of the triangle ABC. Then can we say that B is the orthocenter of triangle AHC? Oh.
I wanted to say one more thing.
What are you gonna say?
So, not saying like as if this is going to hop in a tournament, but I found this game where I haven't played in such a long time. It's called Fall Guys. It's an online game.
Yeah, Fall Guys. I used to play Fall Guys. I think I have it somewhere.
Would you ever want to play that with us? Not in this tournament, though.
Yeah, we could play sometime. I think you have to pay for it, though, no? It's not free, right?
No, it's free. It's free to play.
Fall Guys is free?
Go to Epic Games Launcher and just install it. It's for free. There's no money.
Oh, I'm pretty sure I got it on Steam at some point. Yeah.
Well, there's nothing of the sort.
Okay.
But I'll go now. Thanks for the help, man.
You're welcome, dude. Nice. Okay. If H is the orthocenter of triangle ABC, then can we say that B is the orthocenter of triangle AHC? Wait, what? No. What? H is the orthocenter of triangle ABC. Okay. So I mean, I see this, right? I see this triangle, and I see an orthocenter. But then AHC would be this. How is this going to be the orthocenter? That makes no sense. Yeah, B is not in... Yeah, right? Yeah, B isn't inside AHC. Yeah. I don't know if that makes sense. In an obtuse triangle, altitudes are sometimes outside the triangle sometimes. Okay, okay. But wouldn't the... Yeah, so the... Oh, I see what you're saying. Yeah. Okay. Because, okay. Orthocenter, I believe, is where, yeah, you take a side, and you take a 90-degree angle, and then it goes to the opposite side, right? So, let's see for AHC. So for this, you need, let's just, I think I get it. Yeah. Because now this becomes the altitude, right? So now I have to like go out this way. Sib says, is the spherical and cylindrical coordinate stuff hard? It can be kind of confusing, for sure, to visualize. But yeah, just do a lot of problems. Yeah, problems are always the best way to learn, honestly. Okay, I see. So this would be 90 degrees because this is 90 degrees, yeah? And then, so that's from this one. This one goes to here. So I guess the back version of that. Because you want where all the altitudes intersect, right? I see. Well, I mean, by definition, right, of this altitude, it has to go through B. Yeah, Nick, we can do yours. Okay, and then C having to be perpendicular to this side. So, how does that work? I see, yeah. Because where two intersect all three. Yeah, I just want to show where the other one intersects. Yeah, okay, cool. So yes, we can say that B is the orthocenter of triangle AHC. Yeah, BC is the other altitude, right? Yeah. Okay, cool. Yeah, that's pretty cool. All right, Nick, let's do some of yours. Yeah, that's neat, isn't it? Hamiltonian dynamics, isn't that neat? I think it's pretty neat.
Mother chord.
So is gravity just density along a vector? Maybe? Gravity's a force, for sure. Density along a vector. That's an interesting way to put it.
Hello.
What's up, Nick?
It's mass along a vector, but only one type.
Yeah. Okay. Hamiltonian dynamics is like, no. its mass in a two-dimensional space. Well, not really.
We don't live in a two-dimensional universe.
Gravity is imaginary electricity. It's the forbidden electricity. The forbidden free electricity. Okay. All right. Question 1 through 6. Cool. Notes. Inmates can enter a section of the program at any point. Blah, blah, blah. Okay, here we go. Number of inmates enrolled in Libertyville's basic office skills. Symbol. So, victimless crimes. Crimes against property. Violent crimes. And this is just showing over like, I guess this is a 9. Oh, I see. It's a 27-week program. Right? No, 30-week program. Sorry.
10 steps?
Yeah, the 10-step.
For some reason, I can't see stream on Discord.
You can't? Oh.
It's my Wi-Fi.
Your Wi-Fi.
Yeah.
See, what you do is, right, you get this thing called a Cat 5e cable.
Yeah, make sure it's... Or Cat 6, honestly.
I'm outside. I'm in the basement. That's why it's not working.
Oh, he's in the basement.
More reason to have a Cat 5 cable.
Yeah, you definitely... Yeah, you should get a hard line down there.
No, not in my house, though.
Yeah.
I'm outside.
Okay. All right, percentage of recidivism. Isn't that where, like, you... What is recidivism? Is that where you, like, go back to committing crimes?
No.
Yeah, okay. Within first year of parole among inmates who successfully completed... Yeah, oh, Jeff says you commit another crime. Yeah, okay.
There.
Here we go. The percentage of inmates who successfully completed Section 1 and were recidivists is...
there you go.
Okay.
This is very confusing because there's three charts and they also do it at the same.
This chart is really, really weird.
Yeah.
Oh, okay. Well, no. Here we go. Okay. I think you have to do like this percentage times this, and then this percentage times this, and then this percentage times this, to get the total number of inmates that committed another crime. So I think it's 0.4 times 78 plus 0.3 times 43 plus 0.35 times 80. Okay, let's see. Where's our calculator? Okay. Commit crimes. Okay, so 0.4 times 78 plus 0.3 times 43 plus 0.35 times 80. So that gets me 72.1 people were recidivists. And then I want to divide that by the total number of people who completed Section 1. So that's going to be... so the total number is 78 plus 43 plus 80. And now I just do the 72.1 divided by that. What's up, Dr. Cook? Jeff is a McDonald's stan on Reddit. Let it be known. Wow. What does that even mean? He likes McDonald's. I like McDonald's. I had some Taco Bell last night. It was regretful. So I think this is 35%. I think it's answer choice B. Is that right?
I don't know because I'm not next to my book right now.
Okay.
I hope so.
All right, we'll check it later. Jeff's like, the ratio of the number of inmates who started Section 3 the first week to the number who successfully completed after section 3 is most likely. Okay, so how many people started? So on the first week, you have 35 plus 50 plus 60, right? No. Yeah. 35 plus 50 plus 60. And then that's going to 15, 20, 35. So 15, 20 is 35. 35 and 35 is 70. Okay, so here, so it's 145 to 70. So it's about 2 to 1. So I think, yeah, it's like 2.1 to 1. I was reading the front page of Reddit the other day, saw a post trashing McDonald's. The top post was defending McDonald's, and I noticed it was a post by a certain Jeff C. Groves. Oh. Is Jeff Groves, is that like a common name? Is that like a character? We know who Jeff is in the server here. Were you defending McDonald's, Jeff? What's up?
McDonald's Wi-Fi. Is the 9 bond coins or the 10 bond coins, whatever, did it register?
Yeah, it did. Yeah, you got it.
Oh.
I'll do it.
We're waiting.
Okay. During which of the following weeks of the program was the enrollment by those who committed victimless crimes exceeded by both those who committed crimes against property and by those who committed violent crimes? Wow. So basically they're saying where you gotta like kind of dumb this down. Well, they put so many words here. So you want victimless crimes to be the least. So victimless, the least, because that's how it gets exceeded by the other two. So where is victimless the least? Well, right here. So week 3 of section 2. Yeah, okay. That's choice B. Yeah, there's no other time that happens. I guess also during week 5. Yeah. Okay. If the average number of inmates enrolled in any stage of the program is considered to be the number of... Sorry, what? Oh, okay. So week 5 is where they're considering the average number. What is the difference between the average number of inmates, section 1 and section 3? Okay. Well, I think you added it right here, right? 55 plus 75 plus 85. So, yeah, okay, cool. 215. And then here, 30 plus 45 plus 50. So, 215 and 125. Oh, 215 minus 125, which is going to be 90. They want the difference. Yeah. Okay. Assume that the 60% of inmates who complete Section 3 the percentage of the initial oral is...
It's so poorly worded all the time.
My head
So
just hurts just thinking of it, dude. Like what?
Yeah.
%60%. Well, sorry, what? Okay.
Anyone has any thoughts?
I don't
No,
really know
I'm
this
brain dead.
one. I'm brain dead on this one, dude. But... oh, they at least give you the names. They give you the numbers here. Yeah, I don't know how to do this one. I really don't know what's going on. Okay. The one of the following periods which exhibits the greatest percentage change in enrollment of inmates in the crimes against property category is weeks. Okay. Crimes against property, which is this. Greatest percentage increase. Well, it's when you have a low number, but it's spiking a lot. Because percentage change is always like divided by what your initial thing was. So these spikes don't have as big of a percent change as these ones do. So I want to say week 1 of the communication section. Yeah. Fembox, what's up, dude? Yeah. I mean, 2 to 4 also has like some big increases. What's that? That's 50 to 70. But then you divide it by like what you started at, right? Because percentage change. Equals final minus initial. All over initial. So if you're going from 50 to 70, you're only going up 20. And then it's 20 over 50, because that's your initial. So that's 2/5. Versus week 1 to 2, you go from 30 to 50. That's a change of 20. But it's divided by your initial, which is 30. 20 over 30 is 0.6. That's a 67% change. Yeah. Okay, cool. Does that make sense? I don't know how to do the 5th one, but...
yeah.
Alright, cool. Nice.
When I I'll
What's
send
up?
you the answer. This one.
Yeah, I'm curious about that.
Yeah. I'll send it to you when I get home.
Okay, cool.
Thank you.
You're welcome, dude.
This is fun.
This is fun. Oh, dun. Dawn and I pulled the plug on GR. It was getting too hard. Yeah, general relativity is quite difficult. It's funny, like, SR, special relativity, is easier than GR, general relativity. It's one of these weird things where you think, like, the easier sounding class, you know, should be easier, but it's not. Okay. Nice. Okay, I don't think we have any other questions today, so... I do have to go tutor a student, so I'll end the stream so I can go eat some food, take a shower. But okay, cool.
Hold up.
What's
Just
up?
a quick question from me.
Quick question from you, Sensation. What's up?
The double slit experiment.
Yes.
Where do you put the detector to change the outcome?
Ooh. like it's always gonna make a pattern. The distance away that you put it will change the spacing of things, I guess, right? What do you mean to like change the outcome?
So in the 5-slit experiment, there's a way to change the outcome so that you know, because you have observed, you know where it's going. It only ends up going on the 2 slots rather than all 5 of them.
Yeah.
I can't remember how it works exactly.
At the slits, yeah. I mean, I guess if you... The double slit experiment is that you have 2 slits, and then the electrons act like a wave, and then once they go through the slit, this is what happens. It's initially a plane wave, which then at the opening then turns into a spherical wave, which then causes an interference pattern that looks like this. I think if you remove one of the slits, then you no longer get an interference pattern, right? That's like a single slit.
No, it was you put the detectors somewhere.
Oh.
And because you measure it in a particular way, it changes the outcome so it only ever goes straight through the 2 slits.
Okay. I think I see what you're saying. Yeah, it has to do with this is the quantum nature of things, right? That if you know where one thing is, then the other thing. But then can information travel faster than the speed of light? This is the paradox about it. Because what if the 2 detectors were more than like a light year apart or something? Yeah. Winnie's typing something. What's up? What is Winnie typing?
But you don't know what I'm talking about.
I have an idea of what you're talking about. Yeah, it has to do with.
Yes.
It's almost like the Schrodinger cat thing, where, you know, if you perturb the system, our eyes are on the right, and is that why when I looked outside at a street light 50 meters away, I saw it like black and white? What? Winnie, excuse me? What?
Yeah. Please write that again in English, for the fucking love of God, right?
Oh, man.
If English isn't your first language, fine. You can translate. You have a computer.
Yeah, it's okay. Blah. It's okay, Winnie. It's okay. Are our eyes on the right? And is that why I looked at the street light? I saw like.
Don't. You'll have to lose 50 IQ points to understand that.
I'm trying to understand, Winnie, what you're saying. It's okay. It's like when he's typing.
Just wait, I'll go get a hammer and bludgeon myself a bit. Maybe I'll comprehend it.
Okay, here we go. 1 sec. Sensation. What side of the bed you wake up on this morning? What is this? Oh, that pic I was talking about. Yeah. That's called the double slit experiment. It's our eyes are on the right. I think what you mean is like we look at things on the right. Yeah, like here. Light goes through like 2 little pinholes is what happens. Yeah. All right. Let's see if I have time. I do have to run pretty soon after this, but let me see. Show that the matrix 1021 can be decomposed as a sum of a unit and a nilpotent matrix. I don't know what a nilpotent matrix is. Hence, evaluate the matrix 1020 to the 2007. What's a nilpotent matrix? Yeah. Jeff's, if you keep multiplying it by itself, you'll get 0 eventually. Oh, okay, cool. Zero 020 is nilpotent? That's cool. Oh. So omnipotent.
Omnipotent.
It's nil, not nile. Sorry, nilpotent. Sorry, not nilpotent. Yeah. A nilpotent matrix takes you in one direction. Is there the omnipotent matrix?
It's the opposite of omnipotent, isn't it?
A equals I plus M. Yeah. So, yeah, I agree. We're trying to say that, like, how can you write 1, 0, 2, 1 as the unit matrix, which would be 1, 0, 0, 1, or the identity matrix, sorry, plus something else. And then, yes. Also, the power of a nilpotent matrix is always less than or equal to the order of a matrix. Oh, that's cool. And yeah, I agree with that. Right. We can do the binomial theorem. In general, I plus m to the k is equal to I plus k times m. Oh, wait, what? Wait, sorry. I don't know why automod got rid of it. There you go. Because 0 is equal to m squared equals m to the third. Yeah. I see. So only the right. Wait, shouldn't it be? Oh, yeah. Okay, that's very cool, actually. Yeah, because if you have the identity matrix plus m, like, let's say to the third, for example, right? That's equal to I cubed well, here, let's do the square one. I forget the cubed one. Yeah, that's I squared plus 2im plus m squared. But if this is the nilpotent matrix, this is 0. This is 1. And then, so, yes, you get, it's equal to 1 plus, I get it, 2m. But if this is k, right, then it's equal to 1 plus km. Oh, that's very cool, actually. Because the nilpotent matrix always equals 0 when you multiply it by itself and any other higher power. Okay. So I could say that this is equal to 1, 0, 0, 1 and 0, 0, 2, 0, right? That's correct, yeah? Okay, cool. And yeah, I guess this is nilpotent, right? Because if I do 0, 0, 2, 0 times 0, 0, 2, 0, 0 times 0, 0 times 0, 0 zeros, I guess, yeah, no, you're always going to get 0. That's really cool. Yeah, the degree of nilpotency was only 2. Yeah. Okay. So then this is just equal to 1 plus 2007 0, or 2007 times what was it? Times 0020, right? So that's equal to 1001 plus 4014 0. So your final answer is 4014 1. Oh, that's kind of cool. Nilpotent is a great word. Okay, does that make sense? Kushkwant? Anti-material world. Knowledge, the object of knowledge, and the knower make up the threefold impetus underlying action. The instrument, the object, and the agent are the three constituents of action. Oh, okay. Cool story. You do know this is a Wendy's, though, right? Sir, this is a Sir, this is a Wendy's.
This ain't the bookstore.
Yes. Okay.
This is where we brand cattle.
You seem clever. Oh, wow. I do consider myself a clever man sometimes. This is math, not philosophy. Isn't math all philosophy, or all philosophy is math? Yeah.
The ethics of Pythagorean theorem.
The ethical arguments. Math is philosophy in practice. I kind of like that. But philosophy is nothing and not math? Jeff. Okay. Let's see what this is.
Of all the things I've lost, I miss my mind the most.
Is that from Lewis Carroll? Who's that from?
All the things it was supposedly by Ozzy Osbourne, actually.
Oh, that is Ozzy, yeah. Okay. Let x be the solution set of the equation a to the x is equal to the identity matrix, where a is that and I is... Yeah, okay. Find the minimum value of cosine... What is this even saying, dude? What? Excuse me? The xth power of cosine plus the xth power of sine. And then I'm summing them all up? I'm gonna guess x is 2. And then cosine squared plus sine squared is just 1. Yeah. Ooh, Fembox has a problem with geodesics with a cone. Nice. You think a squared is equal to I? I just hope it is, right? Because that's the only way this would just be equal to 1. No, answer is 2. Oh, the answer is 2. Then we have this one as well, but I do have to go. I have to go teach. Sorry, I have to go teach another student. We'll go over this one next time, Fembox, if you want to try. This looks actually kind of fun. Okay, cool. All right, let me close out the stream. All right, thank you everyone for coming. Actual Education Office Hours today. Had a lot of fun answering questions. If you want to come by our stream tomorrow, we'll be streaming at 4 p.m. Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. Come on by, learn some math and science with us. Let's go raid somebody real quick. Sorry, I have to bounce. I gotta go drive to go teach another student in like 10 minutes. Good. Yeah, good to see you, Nick. Let's see. Who are we gonna go raid? Math and play games. That seems kind of fun. Subathon. This guy's just... What is he? Just eating pizza? What's this guy doing? Interesting. Yeah. Good to see you guys. Yeah, let's go here. Everyone loves math? Oh. I can't... Wait, why can't I raid them? I want to raid them. I don't want to raid one of these, like... Okay. Oh! Astro Canuck. He does cool stuff. Astrophotography. Yes, go start the raid. Go say hi to him. Okay, cool. Alright, I gotta go. Enjoy the rest of your Monday. Have a great start to your week. We will see you tomorrow. Peace.